problem that sucks. So should this be in English, or do you mind if it's in English, or do you want it to have it in Icelandic?
This is an English course.
It is an English course, so I'll keep it in English. Should have done that already. Okay, so hello. So for those that are watching, you can check out, you can post questions and I'll most probably see them. Hopefully if my phone doesn't die. All right. So, here we go. Okay, lecture. Alright, so today we'll talk about two new programming languages, or at least one programming language and another, like a foundation under a whole programming paradigm. So basically, Smalltalk is the first thing that we're gonna check out, and the second thing is Lambda calculus. So Lambda calculus is the foundation under every functional programming language out there. So Smalltalk, I think he's gone over this in slides, hasn't he, in lectures, like a little bit at least. I'm just gonna go a bit more in depth into Smalltalk. Just take the example provided on the slides and talk about it, to explain it. Then we'll do a hands-on exercise. So you're gonna get your fingers into Smalltalk to actually get to know it. All right, let's just jump right in. I recommend using a guy that's called Coding Ground. Oh no, sorry, Tutorials Point. And if I just Google it, Tutorial Point. So this website actually has something called Coding Ground here, and as you can see, you have access to a bunch of different programming languages, one of which is Smalltalk. So you can check that out. And here we go. So now we have Smalltalk up and running. So this is what we will use, at least for now, to check out the Smalltalk. However, when you do the programming assignment, please just download the official Smalltalk to your computer. I think that's better to actually, if you're iterating or doing stuff like this might crash or...
Is that assignment 3?
No, that's the programming assignment for, assignment 4, program assignment 2. So assignment 3 is a hand-in, not a programming assignment, it's just a handwritten thing. So, okay. So let's look at an example of this. So I have copied here. This is the example given in lectures. So we have really, well, as you can see, what should I call, a weird looking syntax, bunch of break brackets and pipes and whatnot. But this language is actually more than 40 years old. So as you can might imagine, it's a bit dated. But let's just check out what's cool about it. Now, the designers of Smalltalk had one goal in mind, and that was to have everything in Smalltalk an object. So everything you interact with is an object, and the only thing you do is pass messages to objects to get something from them, or to just interact with them. So the language itself the syntax of the language is really simple. It's messages on objects. So, for example, here you have transcript. This is an object, and this is a message. Show. All right. So, since okay, another thing about Smalltalk is that it was the first widely used programming language which actually used object-oriented thinking or like approach. So it didn't actually, it doesn't have it, but it has functional programming elements to it, but it's oriented purely on object orientation. Okay, so so for example, here you have the transcript. This is an object, and you're sending the message show to it. Okay, and this show has one parameter, which is this string, as you can see. I think this is incorrect. I think you should use like you should use these guys. I think this is a string. I was trying it out earlier. Okay, this is a string, like not double quotes, just single quotes is a string in Smalltalk. The dot is actually the separator, like a semicolon. So one of the other design goals was to have the syntax as readable as possible. So they thought, why not have the dot as the separator instead of a semicolon? Because, well, language uses dot. So, and as you can see, actually don't use the dot to actually indicate that you're calling a method. Just use a space, like, and like their like goal was to have like as fluid text. You could read the lines and just understand what was going on. Okay. The first thing you would note is that you have pipe and then you have like SFC. This is basically declaring the variables. So you have variable declaration before you actually use them. So this program will use 3 variables. C, F, S. Wrong order. Alright, so since everything is a message, there's no like there are almost no, I think there are no keywords in the language. And when I say keywords, I mean, for example, if you say for a for loop, or if you say an if statement, or new for new things, there's no keyword for this. Like in Java or C++ or anywhere like in normal object-oriented languages, you have keywords for like looping over things, like a for loop or a do-while loop or something like that. But in Smalltalk, you don't have this concept. You're only passing messages. And let's just take a look at this program, for example. Okay, so like we said before, we're calling this transcript object. We're sending the show message to this transcript object with the enter a line as parameter. Okay, that's what happening here. This is basically like print line. Just print this on the screen. And what happens here is basically get the next line from the standard in. So I'm sending the message next line to standard in, and getting what's returned from here. So when I say messages, this is what they use to call things, but well, in reality, it's just functions. Like you're calling a function next line, and it gives you a string as output, as a returner. So this is just a function. You can think of it just as a function. Okay. Or what's happening here? This is something like different from usually when you do stuff. Like usually when you use new objects or a new instance of objects, you use the new keyword. This isn't the case here. Like what's happening here? You're actually just calling the message new on the object back. So you're getting a new back without actually using any keywords. You see? Like in Java, you would say like back equals f equals new back, something like that. Where this keyword, this new thing, would be a keyword, restricted keyword. Now, it's actually in Smalltalk, you actually just send the message to the back, and he gives you a new instance. Okay, so the f is just a new back. All right, we got that covered. However, as I said before, there's no hooks. Like there's no restricted. Like there's no for in this language. You can't do like for int I equals something something.
Well, without the back.
The back, yes.
When you would that be a function inside of the back?
Yeah. Yeah.
Just like the show is a function.
Yeah, definitely. So basically the question was like the new message that you're passing to the back is just a function. It's just a function as any other function, and it just knows how to create a new back. Yeah. Okay. So as I was saying, like here we have, okay, what's S? Just quickly, what's S? A string, right? So if I want to like iterate over all the elements of the string, all the characters, how would I do it? Normally, you would like in a C++ fashion. You would do a for loop with I equals 0, then iterate like every step, and then check if the length is more than blah blah blah. Okay. Well, we don't have for loops in this. We do have something called do. We have something called do. So what this does, this is just a message. Okay, this is a message on the string type that says, okay, do the following over every element of my list or of my collection. So this thing, the basis, we're just defining a block. Okay, this is just a code block. So call this code block for every character in the string. That's what the do statement is telling us. Basically, do everything in here, do the following. Take the element, place it inside character, like ch, place it inside ch, and run it for every element. That's what's happening in do.
Does not say that it should run on all element of this selector? Or like this?
Oh, it says like, okay, if you ignore this completely, skip this, and just say ... I'm gonna this would basically say iterate over it every character, and then once you actually got the character, you can filter them out anything what you want to them. It's just like a function. You're passing the do a function which takes in this one character element, like every character do this. And if you've probably done for each loops in other programming languages. This is just a for each loop. For every element, do this. Right? Makes sense. Right, so, however, as you don't actually have any keywords, for example, the if statement, how do you actually do branching? Well, this is actually returning something called bool object. This is a Boolean object. Well, the bool object can be passed, you can pass messages to the bool object. So if you pass the message, are you true? And if so, please run this code block. Then you've done the branching. Like it works. So basically, like what happens inside this block is that for every element, I'm going to check that if this is a letter, I know that the return of this the thing that I highlighted will be a Boolean. Okay, and then I'm going to call if true on the Boolean, and then give that basically a code block to execute. It's true. See how the functions, like you're giving a code block to a code block. And if it's true, then what I'm going to do? If it's a letter, what happens? We add it to the back, but we add it as a lowercase. We call the lowercase message on the character, then put that into the back. Okay, does this then make sense? Like, what's happening? Okay, if you describe it in like one sentence, what is this code block doing? Like, what is this code doing? And yes, so for every letter in the string, he lowercases it and puts it into the back.
And you don't know for sure if it comes out as the same string mode.
No, you don't.
Depends on that.
Yeah, and also the string. If the string contains like a digits or something that's not a letter, well, that won't be added into the back. You see, like if it's a letter, then I'm gonna add. If it's not, I'm gonna ignore it. So the code block is basically iterating over the string, picking every letter, lowercasing it, and putting it into the back. Okay.
One question. Can you pick the diagonal?
Yes.
Line 4.
Line 4 here.
Yeah. You're calling the new function in the back object.
Yep.
In line 7.
Line 7.
You want to add, that is, you have it back. You call the add function, I guess.
Mm-hmm.
If you have the semicolon.
Oh.
Yeah, and you don't have it on the.
Yeah. So when you're passing messages, the question was like, you have the semicolon here, but you don't have it here. What's happening? So basically, if you have a semicolon, well, so a semicolon states that there's a parameter. So for example, here show has a parameter. So after the semicolon, the parameters will be declared. So the new function actually doesn't have a parameter. It's just a parameterless function. So that's why you don't have the semicolon here. This actually has one parameter. Cool. Okay. With that said, what happens here? Like, oh, I think you're starting to pros at small talk. So what happens here? 1 to 26. Yeah, it's just I'm gonna build a collection from 1 to 26. So all of the integers from 1 to 26. And then I'm gonna do something on them. See, it's the same do here. So this is basically creating a sequence from 1 to 26. And once that sequence is created, you can do stuff on it. You do this code block, this code block. Okay? What does this code block tell us? We got this I. The I is the integer 1 to 26, some of them, like you're iterating over them. So what is happening here? What do I need this for? Sorry. It's just local to this block. That's before, so referring to, well, don't you have to do? It's basically whatever you want. You can say like yellow. Like this is just a variable name. Yes, uppercase. So close. Uppercase. Yes. So it's a lowercase. 97 is a lowercase a. So it's a lowercase, basically. But I'm not printing out the alphabet. I'm printing out the alphabet and something else also. So basically, I'm getting the character for 1 to 26. Okay, I'm getting all the characters. And then I'm gonna show transcript.show. And now this is the first time you see, I'm gonna have this new line. This is a one parameter. So like you're calling the show method on the transcript with two parameters. You can see? Like this is the first parameter. Okay, now this is the first parameter, comma, this is the second parameter. Just like a parameter list, any other programming language you've seen. The only difference is you don't actually put the parentheses if it's only one element. For example, like here, it's just one element, like one thing that you're passing to the function. If there are multiple things, well, you put thing around it. All right, braces. All right, so I'm going to print out something. I'm going to print out what's happening here. saying F, calling occurrences of C, F.
Yes, C is a parameter that we send.
So it's here. So what's happening is basically going through the alphabet, and for every letter of the alphabet, I'm checking my back and seeing how many occurrences of that letter occurred in the input. So you can see number of occurrences, or occurrences of C, basically tells us the number of occurrences in F C was, basically. Then this print string is just getting, like, it's taking the integer, putting it into a string. So that's just like a toString or like string int string or something in C++. And then you're putting like second parameter to the show function. It's basically saying please add a space between. So that's basically here. Okay. So now you're pros at this. You can do this, I believe.
Is this so used?
Smalltalk.
Yes.
Maybe like legacy software for banks or somewhere, but it was widely used like 20 years ago or something. So basically, we're going through like, because we're gonna see all the paradigms. We're gonna see the functional paradigm, object-oriented paradigm, and the logical paradigm. This is one of the roots of the object-oriented paradigms. Like Smalltalk was one of the first programming languages that actually brought to the notion of object-oriented things. And actually, the developers of Smalltalk were so dedicated to the idea that it was so simple to just have messages that you will see later on. They totally ignored the correct order of arithmetic. So yeah, we'll see that. Oh, okay. So lab class. Let's look at the class. What I'm supposed to teach you. So experiment the date class. So please fire up this site. So this site, the thing I showed you before, because now it's useful to check out what's happening. Okay, I hope I can show you. Okay. So the first thing is like create a new instance of the date class using the class method today. So you know that we have, yeah, by the way, I'm gonna just use this terminal. Like you can use either or this guy or this terminal, but I'm gonna use this terminal, like TST, and now you get the Smalltalk terminal where you can do anything you want in Smalltalk. Sorry. Okay. So we should create a new instance of the date class using today. Well, we got our trusted manual in hand, I think somewhere. Wait. So there is something called a library reference from GNU, and it has the functions that are available on the date class. So we're supposed to call the date class, and let's just do it, date, and then we're gonna give me something. Let's do something crazy. A name. Yeah, that's totally awesome. I failed. So basically, what happens if Smalltalk doesn't recognize something? For example, now I called the method on the Smalltalk on the date object that it didn't recognize. So basically, function was not defined. We'll give you something like don't understand this thing. date name. But yeah, I'm gonna just do the thing that I'm supposed to do. Today. Woo! Something. Okay, so we got the day object. However, the only yes, sorry, I'm forgetting something. So basically, another thing about small talk is, if I'm gonna go back, sorry for this, but go back to this example. As you can see, there's nothing that declares what type each object is. So we got SFC here, we got these variables. As you can see, there's nothing defining what should be put into each variable. So there's no type safety. Like there's no type safe way to interact. Like Smalltalk doesn't have type safety. What that means is, well, if you try to call a function on a variable, he won't actually check if that function is available on the variable until he calls it at runtime. So he doesn't check it at compile time. So you will get the errors of runtime checking, like all the function calls that you get. So when people say, yeah, when you're object oriented, like you can use type checking because that's always hand in hand. Well, no, not necessarily, because the type system is independent of the type of programming language. Like you can have type safe functional programming languages and object oriented programming languages. You can have both. So if someone tries to fool you, you'd know better. Okay, so let's look at this, and then I have something besides. Okay, let's just look at this. Can I zoom a little bit more? Okay, this is large enough to see. Okay, so what we're supposed to do is get this, get an instance of this into a variable. Let's do it. So I'm going to define a d and say date today. So it says false. Yeah, of course. Sorry, yeah, another thing, you have to use colon. Otherwise it says, yeah, d is not the same as today. Okay, so here I declared the variable d. I've not used d, which is undefined. Okay, so now I have d. What can I do? And one of the exercises was like, we should get the name of the day. So day name. Wednesday. Woo! Cool. So we got Wednesday. So as you can see, you just have a reference to this object, and you can pass messages to it as you like. Okay. So let's look at what.
You are creating a new variable like either. Don't you have to define the type of what?
No.
I mean, there is.
So D is an object, like is an instance of date. But you can see I can change the value of D at any time. It's like Python.
Is it like the object, the numbers, like the
Yep.
and the operation 2, 1, 2, 26. For example, so that
Yeah. Okay. Sorry.
2 would then be a function on the integer.
So
The 2 function would know how to
yes.
compare. And if you create a new object, would you have to define the type?
Not in Smalltalk. So no, basically. So basically, you could say, for example, if I take this expression and let's look at what this expression does. Like I said, 1, 2, 26. And it says, here's the type. It's an interval between 1 and 26. So you don't actually have to apply anything to it. You could say like, okay, let's make this a d. and here you got D, and if I do the P, you'll tell me.
Before you said you ran D name, and then would you be able to do D2?
Yeah. Sorry. So D.
If you assign again D equals state today or something.
Okay. Yeah, right. So. Okay. 226. Well, no, because the date object doesn't have the to method. Oh, wait, sorry. It definitely is a data object. You just can't define it beforehand. It's a loose type. Okay. Cool. Let's do this again. Okay, we got our today. We have known how to do the Wednesday. Okay, we should now use something else. Name of the day and number of days in the month. So I thought it was something like, let's do days in month. Guess 28. That's good. It's not a leap year. Okay, so it's 28 days. So the next thing, C is like create a new instance of the date class using the class method new, day, year. Okay, so let's call it O for other. So we're gonna call new day 128, 26, okay. And year 2014. No, 14. Sorry. Oh! So, as you can see now, the thing that I'm doing, if I run this, so I got like 8th of May 2014. Okay, so what I'm doing actually is, here I'm actually calling the date function with, I'm calling new day on the date object, and that actually returns another date instance, which then I call year on. So if I do this, exclude the year, what happens? Crash. All the way around. Year. Do this. I'm just bullshitting you. It's okay. Oh no, wait. I think I know the reason. Yep, I'm just bullshitting you. It's okay. Okay, so we got this new date. Oh, which is 8th of May, 2014, and we're supposed to check. At this point, you should have two references to the date instance. Write an expression that calculates the difference between the two dates using subtract date. Okay. So there's an instance method of the date class. So should I be able to do like O subtract date D? Yes, I should. Or it wasn't the thing that I wanted. I wanted a plus number. So there are 1,024 days since 2014, May 8th. And I suspect that this is the date that the exam was when this originally was created. So you'd get a plus number in advance. So yeah. Does it feel like 1,000 days? 1,000 days! Wow. Time flies. Okay. Oh, let's move on. So, let's look at this. So here we can actually do this. Okay, so the thing that I said before, like the small talk developers or the team that designed Smalltalk, well, they didn't actually care that much about the arithmetic precedence. So let's say we have this expression, 3 plus 4 times 2. What do you think will be printed out? Like, what should be printed out? Should be 8. Let's try. True. So of course it's 5. Of course, that makes perfect sense. Do you imagine getting a bug like this in your program? You're like, what is going on? So when you actually were developing Smalltalk, you just had to deal with the fact that you had to put a lot of places to get the correct thing. Yeah, what happens is that they just treat it as a message. Like 6 is getting the message plus, and like 4 is getting the message 2, like divide. So divide. It's just like, I'll take this argument and then like do that before. No, do the plus before. Sorry. So what will happen here in the next thing? What do you think? So we have 1 plus 3, get it, plus 3, okay. What do you think the output will be? -2. Wait, that doesn't make sense. That should be 1 -2. That's probably because I accidentally put a 1 plus and then pressed enter. Yeah, it's -2. This is confusing. I'm gonna do it again. -2. Definitely -2. Okay. So I think this will have no effect, like putting the parentheses, because that's actually what's happening. -2. But what people might expect this would return is this. Like, we would negate the thing entirely. -4. Okay. There's another thing. So here we have something that says 2 to the power, or raised 2. So basically, in which power is it? So if I do like 2 and 4, then you get 16. You do 2 and 5, you get 32, and so forth and so on. So my question is, what happens if I do this? $10 or 32? Which one? So it's either 2 in the power of 3 plus 2 or 2 in the power of 5. It's actually 2 in the power of 5. This is not consistent. Exactly. So it's, yeah, as you can see, like the precedence order of things is wacky. What happens here is that like the 2 is getting being called with this function, and the function will take one parameter. This entire thing will be called as the parameter. We got this entire thing called as the parameter.
It was invented 40 years ago. At that time,
it was marvelous. So that, yeah, it's like the old language had its merit. Okay, so like this is just to like inform you that even though math, like you should expect programming languages to actually like follow the rules of math, while some of them don't. So This is, for example, this one. But like all modern languages do follow them. Okay, so the next thing we should experiment with is the ordered collection class. How much time? Like, I check my time because I overshoot the times sometimes. Like today, I've overshot the time 2 times. Yeah, I teach them. I teach 2 classes. Overshot the time in both cases. So, ordered collection class. Well, we do it by doing just what you would expect. I'm gonna get through and say my collection, or just say C because I'm lazy. C order collection new. Oh, see. So I got this ordered collection, and I'm supposed to add 10 integers into it. So what I could do is just say like C at 1. Whoa. Yeah, sorry. Semicolon, because it's a parameter. C at 1. I added a 1. I added a 2. I'm lazy, so I'll do 3, 2, 10. And for everything that you get, I'm going to say pipe C at I. So what I'm doing? I'm doing an iterator from 3 to 10, and for each element I'm going to add this to the back, and lo and behold it doesn't work because I forgot again to use the column. Lo and behold it doesn't work again. Yeah, sorry, and do this, and yes, we got this. So what I can do now is basically use the same for loop that we've seen before. This. C do something, and for every element in my collection, let's do it. Let's call it I for item. I'm gonna do run. Oh, do like I. Just there you go. Just print out everything. Awesome. Or what I could do if I'm gonna follow the usual standards, I go transcript, I think it's right. Transcript. Show and parameters is I, comma string, and this was like a so. Go. You can see the print string here in before. Okay, so I've printed everything out here. Okay, so I've printed things out. What should I do next? Since it's so the bonus of having a non-type safe system is that, well, if you have a collection, it's just a collection. It doesn't matter what's in the collection. You can add anything, like anything. So if I do like C at T, this is the date today. So do you think this is possible? I have a collection of integers. Can I add a date to it? Well, yes, I can. So let's iterate over and print again. See? Like up to 10, and then we got this date variable. So we got a collection of everything. You can add anything. So if I add another thing, let's add the string something. This is a long string. Clear enough? Long. This is a long string, and this is a long string. So like collections aren't like fixed to one certain type. You can have a collection that collects anything. So what's the benefit of doing that? Like, what's the benefit of having a non-type safe system? It allows you to do anything. Like, it allows you to do things much more quickly without actually restricting your thing. Like, when you're programming in Python, it doesn't actually restrict you to actually do the proper work, so you can actually just figure out on the fly, and just it's faster to iterate on. However, the downside is of course, yeah, like you get more bugs because the compiler doesn't help you as much, or help you, restrict you, whatever you call it. So, for example, this would be a nightmare to like debug if you had a collection of like, think of any object-oriented language, and you would get a collection of objects. Like, can I use that? Can I do anything with it? Like, I don't know. What kind of object are there? And you're just hoping that the objects, all the objects, can have this kind of function or something. So it's pros and cons for both. But I think this is basically it. Now we're gonna move on to lambda calculus. Unless there are any questions, and I'm still monitoring the feed, by the way, so please ask questions. Okay, lambda calculus. Or do you have any questions about small talk?
It's a component, right?
Yeah. Or it can be. I think it's also interpreted. So the thing that I was doing, that's an interpreter that does that. It's like an interactive thing. Alright, lambda calculus is a fantastic thing, and we're going to learn all about it following Java expressions into lambda calculus notation. And before we jump right into that, I'm gonna head on here and switch this to Lisp, because that's the okay. So if we usually, when we have any operation in normal programming languages, like this 1 + 2, well, this is inline function, like 1 and 2, and the operation is in the middle, right? Well, in lambda, we'd have +1, 2. This is postfix, like prefix, sorry. So lambda calculus is inherently prefix notation, because this operation will be applied to these arguments. Okay. So if I had something more, for example, sinus of these two, well, then you just put on sin will be applied. It's just a normal function, like just like plus or minus, will be applied to the +2. So this function will be applied to the return of this function. So every parentheses that you see in lambda calculus is a function. So you're dealing with functions, totally function, just functions. So now you're on the other side, like small talk, everything was an object. Now everything is a function. Okay. Let's look at this example that we should do. Oh, it's like sin +3. Okay, so let's say here we have Java, and the Java syntax looks like this. Lambda should then look like what? Sin of +x3. There we go. Does that make sense?
You have to have the basis on.
No, we don't, but I prefer them because they are included in the structure. Like, there are variations of functional languages that actually allow you to do like drop this and actually have this in line, because like so, but that's not the like pure version of the lambda calculus. And we're just going to use this version that we saw like 3 times ago. So that would basically not define to the standard. However, let's go back to this example. Note that since there are only 2 expressions, and now I'm gonna bear in mind, like this actually won't actually be like this. It will be like that. So the plus operation will be applied on x, and that function plus x will be applied to 3. And that function be applied to sin. See, it's nesting. It's called currying. Basically, every function has an operation and some argument. And if it's multiple arguments, well, then you just have nested functions. Like plus x is just saying I'm doing a plus operation on x, okay? But the thing that I will return needs an argument, and I will plus an x to that. So you have to draw yourself out of the object-oriented mindset and go into the functional mindset of everything's a function. So every layer of my function is another function. Like there's a functions inside of functions. Okay. But for now, we'll just keep it simple and say x takes 2 parameters. Plus takes 2 parameters, sorry. Okay. So next thing we should change is this. So Java looks like so. Lambda looks like what?
And then take y as an argument.
Yep.
And then you apply plus x.
Yes. So what you got is basically this will be applied first, and then this will be applied on these 2 arguments. So if you think about it, the plus will be applied later, right? You have to evaluate the right-hand side and the left-hand side before you apply the plus. And to evaluate the left-hand side, in this case, requires you to actually execute the length function. Does that make sense? So what will happen in this case? Well, you apply plus to length of y and z. You see how I structured it? And actually, lambda actually tells us exactly how the execution order of the Java code actually will apply. It tells us you first calculate the length, then you apply the plus on the result of length and y and z. So you got this inherent structure in the lambda function that it tells you exactly how the execution order will occur. Okay, and now we go. So I've shown you the pool. Now I'm going to throw you into the deep side. Okay. So we got this function. This is a Java function. So we got this public static int quote. What? No. Double x, double n, returning an int cast of x divided by n. So this is the Java. How is the lambda? And don't get intimidated by all the syntax. What is the core thing that this function is doing? Returning x divided by n. And it's taking in 2 parameters, x and n. So that's what the function is doing. It takes in 2 parameters and it returns the division of them. Well, in lambda, up to this point you haven't seen how you take in parameters. You've just seen functions that use 3 variables. But actually in lambda calculus, if I go and show you, there's an expression called lambda var. And this is the thing that you use when you're defining how a function takes in the parameter. So let's check that out. I think I'm gonna copy this here because I don't want to find the lambda again. So okay, so we got this. We got this x. We got this n. So let's just remove this n. So here we have an x, here we have an n, and what this does is actually just x divided by n. This is how the lambda would look like. It takes in two parameters, x and n, and divides them together. Oh no! Oh no! Why you die? Alright. Okay, where was I? Yeah, okay. So basically, in lambda calculus, the way you take in parameters is defining lambda and the variable name, or the parameter name. So here you have a function. This function includes one parameter, that's this parameter, and that function will return another function which takes in one parameter, which is this parameter, and at last we'll divide them together. So you're gonna try to think how the lambda calculus works. Well, there's only one parameter to every function. So if you want more than one parameter, then you just have to return a function that takes in the second parameter. So you have to think about everything as a function. So if you're going to take in multiple parameters, you just return multiple stages of your function. So for example, how you would call this function, I'm just going to call it, you would actually apply a number or another function or something to the end of it. So for example, I'm going to call it with 5. Let's say that. Just 5, not 5 and 6 or something. And note that this is just one parameter. I'm just populating one parameter. And what happens, and this is really like, I would recommend that you do it in your hands because this is like takes practice to actually get a rhythm, but it's a pretty neat formula. Basically, you check, okay, the 5 that's going into the function, you check like, okay, does the function have a lambda? So the outermost braces, you check, okay, I'm gonna carry this input into my function, and the 5 will go where the x is. So basically I'm gonna do it. So 5, you take it, you check, wait. You take a 5, break 3, and remove the x and take everywhere that the x was and replace it by the 5. So every occurrence of the lambda, you replace it with a variable that you're passing into the function, or the thing that you're passing into the function. Note, you can't pass a function into a function. So that would you just take the whole function and just paste it everywhere. So note that now actually, oh wait, I'm doing it all wrong. Why did you tell me? Here we go. I'm sorry, there was an error in my code. Of course, this is how it should be structured. Okay, so as you can see, what happened when I pass a 5 into this function, the return, like what I got as a result, is another function that only takes in one parameter and will always divide that parameter by 5. You see? Like 5 divided by the parameter you give me. Yeah. So if I take this function and give it 2 or 10, then this function actually, like if I do the same thing again, I check like what is the lambda of this outermost parentheses? N. So I take 10, replace n with 10, and remove the parameter, or remove the lambda. So here we got almost the results, and right. So you see the initial steps, like how to do it. Okay, so I'm running out of time. I know. We're gonna check out the actual exercise. Okay, so reduce this to a normal form. So when you're asked to reduce something to the normal form, it's just like the function, the thing that you're given is not fully reduced. Like, how can you take this parameter and place it into? Can you try to reduce it more? So let's take this guy as an example, or this is the thing that we should do. We can do Lisp. Can I hit Lisp? Lisp. There we go. Okay. So we're passing a 4 into this function. So what should happen is that we got plus 4, 3. You see, 4 here breaks the parentheses, places itself where x is, and there you go. You got yourself 4 plus 3, which is 7. Cool. Now we're going into the tuple. What happens here? And now our usual tactic doesn't work. Like, we look at the outermost places and see, hey, there's no lambda function here. There's no lambda. Like, where are you? Well, if that happens, then you just have to move one step closer. Like, go into the brackets, go into the function and see, okay, well, if you don't have a lambda there, well, then this mustn't be on normal form. We have to reduce this.
But they are on the same level. I, the y, yeah.
Yeah, they're on the same level, which means that this function here, will get this as an input. So you do the exact same thing. You take this thing. Okay, wait, I'm gonna clone this. You take this thing and place it everywhere you see an F. So you saw an F here. I'm gonna remove it. And here you see an F, so I'm gonna paste the function, and here I see another F. Paste the function. You see? So every time you see the variable that you're supposed to reduce, then you just place it there 2 times. So this entire thing will be placed into the F. Okay, makes sense. Okay, so what happens now? Well, first thing we do is remove these unnecessary parentheses. And what happens after that? We can replace the x. So we take 5 and plug it here because that's the only x. And remove this thing, and now we have this thing. What happens now? So is there a lambda? So now the question is, should we move into the function or should we just keep ourselves on upper level? So should we take this entire thing and place that into the y? Or should we go into it and place this 5 into this guy?
I think you would have to take the second function, not the y, and the
Yeah, so basically there's no right approach here. It's just which one do you prefer? And the difference is that if you don't go into the functions, then you're lazy. And if you go into the function, you're called eager. So that there's 2 different types of evaluation, eager or lazy. And lazy evaluation doesn't actually try to evaluate until it absolutely has to. So instead of trying to evaluate one of the functions, you just continue to merge them together until you absolutely have something that you know you can actually execute. And there's also another difference, but okay. Let's look at this by doing so. You can, but you don't have to. Okay, so let's take this, get the second option, take this, and place it into this this program. Here we go. And now we can actually remove the outermost braces because they are not necessary. Now we got what left? we got this 5, right? Because this isn't a lambda, so this is fully evaluated. This so we got this 5, and we're gonna place it inside this y. So bam, 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 and wait, sorry. And this is basically it, like so. Therefore, we got, what's this? 10 times 2. We got 20. Okay.
Will the equal approach give us the same result?
Yeah, it would give you the same result. The equal approach would give you the same result. So, yeah, it's okay. Before I move on, I'm first gonna like ask. Let's try to describe the function itself. Like, let's take this simple function and try to explain it in words. Like, what is this function doing? Like, what do you think this is doing? This function here.
Just taking one argument and putting it into y.
Okay. And what's that?
And returns a y.
Yeah. So basically, it's correct. You're correct. So you take the input that you're given and multiply it by 2. That's basically what you're saying. This function multiplies anything that you give it by 2. Right? My question is then, okay, this is a more complex function, but let's look at it. What is this doing? Now I have a function with basically 2 parameters, and it's basically saying I'm gonna take in a function, this is the function, and I'm gonna call that function twice. You see it? I'm gonna call it once here, then I'm gonna call it again here. Okay. So, and we're going to take an x input. So basically what I'm saying is, if I take 5 here, or a better way, let's do it like so. Let's do it like so. This is a more better way to describe what is happening. So, okay. So what does this function do? Actually, it's pretty hard to like comprehend, but actually what is happening is I'm gonna take in the parameter f, and this I'm gonna call f with 5. Then I'm gonna call f again with the result of the first call. You see? Like, I'm gonna call f here. This is f. I'm gonna call it with 5. Right? This is just a function, and this is a number, input. Okay? Then I'm gonna call it again here with the input of this function. The output of this function. And if you think about it, in math, you know that a function is just an f of x. Well, this is just describing f of x. This is just describing this in math. So actually, if you think about it, like here, you're putting a 5 into this program, which accidentally will just drop into this place. Then you're going to pass this as the second parameter. This is the program above. And what you're saying is, okay, I'm going to pass this function, which takes in an argument and multiplies by 2. Then I'm going to take that and apply it 2 times in the function, first passing 5 to it, and then passing the result of it itself. It is really,
Cool.
it's cool, right? It's highly cool. It's like you're passing functions like there's no problem passing functions and function to whatever you want. So like that's the key that you have to like get into a mindset of doing functional programming is the functions themselves can be passed around and called like just anything else. They are the thing that you're using always. Okay, so the next exercise is this. So simplify and reduce the following lambda calculus things. Okay, so I think we're gonna make it. So I'm gonna take this one and then you're gonna take rest. Okay, you ready? So we take this parameter, which is this guy, this function, and apply it to x. And since x is just here, I'm gonna paste it. And I'm gonna wait before I do this. I'm gonna copy it so I can see the stepwise. So this guy is going to go into this function. Okay, so remove this thing and remove this, replace this. Okay. And before I move on, I'm gonna copy it. Reduce the number of svegar, number of parentheses. Okay, here we go. What happens next? Well, this function is passed into the other function, and lo and behold, we get the same function. Bam, bam, bam. So this is the end result. Right? Okay, so next thing is this. So before I do anything, what's the output of this? Which is? Okay, so it's either 1 or -1. Is the 5 the first thing that goes in there? Is it?
I think so.
Okay. So let's just look at it. Like it's either -1 or 1. So we're gonna take this 5. We have to place it in some lambda, and oh no, there's no lambda here. There's no lambda. Like you have to have lambda here to actually break this parentheses and put the 5 in. So since there's no lambda there, well, the expression definitely then is not normal in a normal form. So we just move on and check this expression. So what's the next thing? Okay, here we check. Okay, we have 4 passing into something. Well, this thing actually has a lambda. So this 4 then can be passed into the function. So we take the 4, take the parentheses, and replace it here. Now you can answer. Okay, so one more parenthesis will do. Bam. And basically, this 5 will then be passed into this y. This will be the end result, which is 1. Okay, so another note that you have to keep in mind is that you actually maybe okay. Before we go into that, let's take this thing. What's the output of this?
Function, replace f with that one.
What do you think the output is? The end result. 4. That's correct. Now let's do it. Let's check if that's correct. So basically, we take this function and apply it into the f. So here we go. Okay. So, and we have useless parentheses, I think. Whoa, sorry. Jesus. Okay, these should go away. And here we go. And the next thing is that 3 gets passed into this x. Let's just cut this x down. And which is then 4. Okay. Now, before we move on to the next one, let's see what happens if I have this expression. I'm gonna so what x? Okay, what happens now? How do I reduce this?
So you just have to take the intervals like plus xx and we
Yeah, that's a trick. Like, so when you're doing this, you actually have to think about what variable is it that I have in my hands. Just like if we've gone through the scoping rules, or you have like int x equals 5 somewhere, and then you have some block, and inside that block you have int x equals 3, a 2 or something, and do x plus plus. What x is this? It's the local thing, right? The one that was declared like least time ago, or like in the nearest group. So, for example, this is the same here. Like within these parameters, these two x are defined by this x. Like this is the variable of these two guys. So the only guy when you're passing a 5 into this function, the only guy that you're actually replacing is this guy. This guy. Get it? So that's why you click down. Okay. So that's another thing you have to keep in mind, that the variables that you define in the lambda calculus actually apply to they have scope. Like they have scope to the block that they're in. Okay.
when I said that the intervals you can actually factorize those things.
Yeah. Okay. So the next problem is this, and that's the final problem. And we have 5 minutes left, so that's okay. So before we evaluate this, what gets returned?
Group 1 to that. Group 1 to that.
Well,
Anyone? Do you have any?
yeah, sorry. This way. Sorry, I'm looking at questions from the. Okay. So, let's look at this. So what was your thinking?
Lambda y to the right.
Yes?
This guy there.
This guy
goes into F.
will go into F. But before we do that, what do you think the output will be? Okay, before we actually do this, like, what is this function telling us? It's plus 1 to anything that passed into it. Okay? And we see this again. Here we have something that's calling 2 times. 2 times 2 times, like F and F. And we have this parameter 2 here, which goes into the Y, which means that the initial value passed into F will be 2. So it will be 2 plus 1. So it's like 2 plus 1 plus 1, which is 4. But yeah, let's do this. Hopefully that explains something. Okay, before I actually do this, okay, here we go. We take this, reduce, remove the F. Here we go, we get a lot of, okay. So we got this, I'm gonna remove unnecessary parentheses. Okay, the next step is taking this 2 and putting it into the Y, and now it's really the thing that I was describing, takes effect. Which Y do I replace? Like, should I replace this Y? No, only this Y, right? Because the other Y's are inside these functions. So this Y only applies to the Y here. So okay, I've done that. I'm gonna remove everything that is not needed. Here we go. And here we go. So this is, so which one should I do now? Should I take this parenthesis and put it into the other? Wait, what I'm doing? I'm doing it wrong. I didn't remove the thing. Oh, well, here we go. Here we go. Okay. Use the parentheses again. Okay. This will go into Y. And we remove this. Actually, remove it now. Use the parentheses again. Okay. And then we do 2 goes where? To Y. Bam. And this gets removed. And this 2 gets removed. And now we actually have gotten the thing that I said earlier, like 1 plus 1 plus 2. And then we just evaluate it. Like, this gets to 3. And the end result will be 4. You see, the function that I passed in was 1 plus something, and the initial value was 2 here, and I'm applying it 2 times. So 1 plus something, like 1 plus 2 plus 1. 1 plus 1 plus 1, 2. Oh, fuck. I'm trying to say this. Plus 1 plus 1, 2. Okay. you can show up with colors. Color code your parentheses. That's a good idea for the exam. But yeah, I think the class is over. However, if you have questions, please just ask away, because the other teacher will storm in any moment. Next grade. Yeah, so we have started going over it. Unfortunately, because Ivar went away, it's out. So we're only 2 going over it. So, but we hopefully will get it over the weekend. Okay, coolio. Thank you for watching.